a new one. All right, so we are looking at Unit 2 and defining undefined notions and definitions. All right, so an undefined notion is a concept or shape of geometry that can only be described. Vocabulary, right? So at some point we have to say, this is a line. But what's a line? Well, I'm going to tell you what a line is, and you just have to take my word for it. What's an angle? What's a vertex? What's the side of a parallelogram, right? So those are undefined notions where I'm going to tell you what they are, and you're going to take my word for it. Most of these you should be familiar with already, but someone had to come up with a name for it. So we have a point, a line segment, a line, a ray, and an angle. Are the 5 undefined notions that we use a lot. All right, so a point is a specific location. It has no dimension and is represented by a dot. When I talk about a point, I label it with a letter, typically a capital letter. So I call it A with a point, right? I can talk about it having some kind of a coordinate. Maybe it's 2, 4 is point A. So kind of like we did with our midpoint, or when I was finding using the distance formula, I use a capital letter to define a point. All right, a line segment has a distance and it has 2 specific endpoints. When I talk about a line segment, I talk about those endpoints and I list them. The order doesn't typically matter, usually they're in alphabetical order, but I always put a line segment on top. All right, so line segment has 2 endpoints. When I write it out, I have the 2 endpoints with a line segment on top. If there is a 3rd point on the line, I just kind of ignore it. I don't use it in the naming process. All right, so a line is a straight connected path consisting of 2 or more points. When I talk about a line, it doesn't end. It goes on forever. Right? So if I put a point D on here and I add another point E on here, I can talk about line EF. So what's on top of the 2 letters makes a difference. If it's a line segment, then I just put a little line segment on top. If it's the full line, then I put arrows on either side. So there is a difference between talking about this AB versus this AB. Right? So this one has a distance. I can find the length of it. This distance is infinitely long. Okay. All right. Next we have a ray. Ray is a part of a line that begins at a point and goes through another point on a line in one direction. So this point is F and this point is G. Then I can talk about ray FG. The order that I write the letters determines the direction that my ray goes. So it starts at F, and underneath F is that fixed point, and then it goes towards G, and it never stops, so the G side has the arrow. It makes a difference. All right, angles we use a whole lot. We list angles. It's 2 rays that come together. They share the same starting point. What do I call this point? Oh, yay. It is a vertex. When I name an angle, we can use 1 letter or we can use 3 letters. So if I label these points H to the left, I at the vertex, J on the right, I can call this angle I, or I can call it angle HIJ, or I can call it angle JIH. So the order of the 2 ray sides doesn't really matter too much, but the vertex has to be in the middle. So in geometry, we do a lot of things in a pattern, in a direction. And the order of the letters makes a difference. We're going to get a little bit further on and talk about angles. Angle I is the simplest way to write the angle, but it's not always the best way to write an angle. So it depends on how many angles I'm looking at. Okay. How are we doing so far? Great? Great. Nothing too crazy, right? All right, so we're going to have some definitions using undefined notions. So with these three figures, I want to see how many points there are and how many lines there are, how many segments, how many rays, how many angles. So for problem number 1, how many points do you see? 4. Now, I could talk about points that go along each of these sides, but we're going to be looking at the actual endpoint. So I have 4. Nope. We're just listing how many. How many lines do you see in this picture? 4. It's like all in or none at all? So let me ask the next one. How many line segments do you see in this picture? 4. 4 line segments. How many lines do you see? 0. Nothing continues on. So in order to have a line, you've got to have the arrows continuing on. How many rays do you see? Also 0. How many angles? 4. All right, so take a moment and look at 2 and 3. How are we doing? All right. Let's scroll on. All right, so the distance along a line is described as the length between 2 points on the line based on some unit of measure. So if you have 2 letters without anything on top, I'm asking you to find the distance between them. So for number 4, A through H, I'm looking for the distance from Q to R for A, the distance from R to S for B, the distance from P to Q for C, and so on, right? Looking for distances. So I have some distances that are given, so I'm going to draw on my picture. So from P to T has a length of 20. So I'm going to come up here and put a 20 from P to T. It's a little messy there. All right, then Q to S, from Q to S is 6. All right, and then PQ equals QR equals RS. What does that mean? They all have the same length. They all have the same length. So I can say that line segment PQ is congruent to line segment QR, which is congruent to line segment RS. So the symbol equal with the squiggle on top, it's called a tilde, means is congruent to. And if 2 things are congruent, they have the same measurement. If 2 things are congruent, then they have the same measurement. So if I say that PQ is equal to QR, then I can say line segment PQ is congruent to line segment QR. So I'm going to be a little bit picky on our grammar. Distances are not congruent. Distances can be equal. 4 centimeters equals 4 centimeters. But line segments can't be equal. Line segments themselves cannot be equal, but they can be congruent, looking at their distances. So line segment PQ is not the exact same line segment as QR. They have different endpoints, so they can't be the same, but they can have the same length. All right, so congruent has the same measure. Equal, like they are identical. So I'm looking at the lengths of those. So the way that we show that things are congruent, we like to put little ticker marks in. So I did that earlier with when we're looking at the test review, but if I look from P to Q, I'm going to put one ticker mark in there. It has the same length from Q to R. I'm going to put one ticker length in there, which has the same length from R to S. I'm going to put one ticker mark in there. What is not the same length is S to T, right? It looks like it's a little bit longer, so I'll leave that blank. But if I want to put another ticker mark in, I would need to put two tickers. Okay? All right, so that's all that I know. So based on that information, from Q to R, or sorry, from Q to S is 6. And from Q to R is the same as R to S. So how long is it from Q to R and R to S? 3. And if Q and R to R is the same as R to S, which is the same as P to Q, how long is it from P to Q? 3. So how long is it from P to S then? 9. So then, from P to T is 20. How long is it just S to T? 11. So my recommendation, if you're finding different lengths, fill in what you know in the figure. I like to call it working the figure. Fill out what information you have, then it'll make it easy to go back and get those. All right, so letter A, how long is it from Q to R? 3. How long is it from R to S? 3. How long is it from P to Q? 3. How long is it from S to T? 3. How long is it from R to P? 3. Good. How long is it from R to T? 14. All righty. How long is it from S to P? 9. And from Q to T? 17. So if I have all of the figures marked and they're all distances marked in the figure, it makes the answering the questions go a little bit faster. Okay? All right, you try number 5. Take a moment. Stand for me. Good. Oh, already? Like, let me get your class just so that no one tracks you down. Oops. What's today? 114. How long is it from A to B? 14. And like B to C, C to D, and D to E are all the same, and they're all going to be 4. So filling in my answers. C to D is 4. B to C is 4. D to E is 4. A to B, 14. C to E is 8. A to C is 18. B to E is 12. And then A to D is 22. All right. You rocking? We're rolling. Don't rock off the rocker. That's a song. It's dangerous. All right. So next I have a circle, which is a set of all points that is equidistant around a fixed point called the center. So here's an interesting word. Equidistant. It has 2 parts. Equa and distant. Any guesses on what it means? Equally distant, right? How many sides does a circle have? 10 minutes. Wait, no.
Undefined.
1. I would say 2, the inside and the outside. So not really any sides to a circle. Those are all points that are so many points put together that they make that circle, right? So I do have an inside of the circle, I do have the outside of the circle, but technically I have no sides, like I have sides in a polygon. All right, so the distance along a circular arc is the length of a curve of a circle between 2 points based on some unit of measure. What do I call the entire distance around a circle? The circumference. So the circumference is the total distance around a circle. So we're looking at some arcs, which is a circular arc. We're going to look at some distance around the circle, but not the entire circumference. So looking at number 9, we have circle T. So we name a circle with the actual circle, and we name it with the center. So the circumference all the way around is 18.85. Right? Arc Q to S, which is this arc, Q to S, I lied. So 2 letters, you always want to go the smallest distance from Q to S. This is much smaller than the other. So when you have 2 letters, you want to go the smallest distance from between those two. From Q to S is 7.54. I have some congruency markings. So arc PQ, which I'll put 1 ticker mark, is equal to the length of QR, which I'll put as 1 ticker mark, which is equal to the length of RS, which is 1 ticker mark. So if Q to S is 7.54, and R is essentially kind of the midpoint, how long is it from Q to R? Say it again. Okay, 3.77. 3.77. And then from R to S is going to be 3.77. And then how long is it from Q to P? Also 3.77. So how long is it with this long distance with all of these added together from S to P? I'll get it. If I add up those 3 congruent pieces, welcome back. How long is it from S, hit R, hit Q, hit P? 11.31. So then how long is it from S to P down here? How could I find that out? Good. So the entire circumference, 18.85, minus this red, 11.31. So how long is it from that small distance S to P? 7.54. Right, so I just worked the circle, filled in all my information in the picture. So what is the length of arc QR? 3.77. And B, arc RS. And C, arc PQ. All right, how about arc SP, the shorter distance from S to P? 7.54. Arc RP, 7.54. Arc RSP. So there's 3 letters. I've got to start at R. I have to touch S and then end at P. So I like to highlight these because they get a little confusing, but I'm starting at R, I'm touching S, and I'm hitting P. That will be this arc here. It is 11.31. Right. My next one is dealing with our PQS. So I'm starting at P, I'm touching Q, and I'm ending at S. P to Q to S. So that's 3 sets of 3.77. So that's the entire red, which is 11.31. And then my last one. So I have Q to S to P. So from Q touch S, finish at P. So it is a lot of the circle. What is it going to be? 15.08. All right, you do it. Very Charlie Brownish, right?
Yeah.
All right, so I actually cannot take 10 minutes. Okay. Because of absolutely. Please use calculators. There will rarely be a time in geometry where I tell you not to use a calculator. All right, how's life? Okay. How are you doing at home?
I'm a little concerned. Are you okay?
I'm so sorry.
I'm sorry. I cannot use audio on a laptop with the. Okay. We good? Questions?
How did we get A to B on? I forgot.
A to B?
Yeah.
So letter D, right?
Yeah.
All right, so let me get my handy dandy highlighter out. So arc A to B is the shortest distance from A to B, which is going to be here. So if I know that these three pieces are 22.62, then this is going to be the entire circumference, 113.10, minus 3 sets of this 22.62. That's how I got A to B, the 45.24. So I know the whole thing. I know 3 pieces of it. So I'm looking for that, the rest of it, the piece that's missing from the whole circumference. Okay. All right. 2 postulates. A postulate is a geometric statement that I can't prove. We will do some theorems in geometry where I can prove them. And we will prove doing some 2-column proofs. But a postulate, you just have to take my word for it. It's like a definition. It works. All right. I did not come up with these. This is not a Tyche postulate. Someone else came up with these, and they're pretty true to self. All right. So we have a segment addition postulate. I can add segments. Are you okay with adding segments? Right. If I add segments, I get a longer segment. Right. But I can add them together. So we're given 2 points on the line segment A to C, and a third point B lies on the line segment AC. So I start at A, I end at C, B is somewhere in between. So this is true if and only if. So if and only if statements, I can read them backwards and forwards and they still have to be true. So if and only if the distances between the points meet the requirements of the equation AB plus BC equals AC. So looking at my picture here, AB is the left side of the line segment. BC is the right side of the line segment, and AC is the entire line segment. So B does not have to be the midpoint. It will partition it somewhere, but I don't really need to know where. But it just says that I can add up the pieces and it gives me the whole. You okay with that? It makes sense, right? So then underneath the picture here, we have different numbers that makes it work. All right, and then we have the angle addition postulate, where it says if you place 2 angles side by side, sharing a ray, then the measure of the resulting angle will be equal to the sum of the 2 original angle measures. So here I have 2 angles. Here are 2 angles. One of them is a 30-degree angle. The other one is a 50-degree angle. They are not touching at this point. They're not touching at this point. Okay? If I put them together, where they share a side or a ray, here is the ray that they share, and the vertex will be the same. They are now adjacent angles. They are adjacent angles. Adjacent meaning next to each other, and then they share a side. So if you think of like a townhouse, those are adjacent. I can add together the 2 angle measurements. So I can add up the 30 and the 50, and that gives me the total 80 degrees. Are you okay with that? Talk to me, CJ.
If these are postulates, then how are you not being able to, you just proved them? So
I proved it with one example with those numbers. In order to prove it, I would need to use every number that I could have for an angle.
Okay.
So 1 and 2, 2 and 3, 3 and 4, 5 and 6, 1.1, 2.4, like all the decimals. So it is physically impossible to list out every single angle for it to work, because that's how I would have to prove it.
Okay.
Right. So don't get hung up on the postulate versus the theorem. It just means that I can't do a geometric proof with generic information. I can prove it with specific numbers. So a word of caution. If I want, looking at this picture here, I want to find the measure of angle L. So this little m, when we're talking about angles, we measure them typically in degrees. We'll talk about radians, but that's a little later. So this says the measure of angle L is, and then a blank. So this m is the measure of. So if I look at that middle picture, what is the measure of angle L? L being the vertex. 80 degrees is one possible answer. Or I could say 30 degrees. Or I could say 50 degrees. Because in this picture, how many angles have angle L as the vertex? 3 of them. So angle L is the most common way to name an angle, but it is the most misused way to name an angle if they share, there's two angles that share a side. So maybe I was looking for the 80, but you said it was 30 or 50, right? Who's right and who's wrong? Technically, angle L could be all of those. So if you're looking for a specific angle that has multiple vertices, or multiple vertices come from the same angle, I will look for the measure of angle BLD. Angle BLD tells you specifically which angle to use. So this BLD, I start at B, I hit L as my vertex, and then I end at D. So what is the measure of angle BLD? That one is 80 degrees. For the other one, I can look at the one on the left. I can look at measure of angle BLR. And then the one on the right, the measure an angle RLD. So just be careful, if there's more than one vertex at that angle, I won't know which one you're talking about. So if you were to, bless you, name an angle, if I said which angle has a measure of 50 degrees and you say angle L, I will answer you which one, right? Because there's 3 of them there, right? So just be careful. Okay, I have some homework for you. It looks super lengthy. Yes. There are 2 pages. So we are looking for, let me stop my screen share. We're looking at the angle addition postulate and the segment addition postulate. These 2 are homeworks. There we go. That will be due on Tuesday. So you got plenty of time to get them done on your 3 plus day weekend. Okay. Okay.
Do you have anything with the name?
Who was they?
I don't know.
Sometimes there are people on the roof who they work on the heat. Sometimes when the heat kicks on or turns off, then it makes that noise. What's HVAC? Heating,
Oh, no, I hope I don't.
the air conditioning. HV.
Oh, I don't know. Someone's video.
Is there one?
What's the one just fall through the roof?
So that was a long session. Okay, so got some homework to work on. For my at-home folks, please let me know if you have any questions, either through Remind or through Canvas or email, and I'll be more than happy to answer those for you. But these are the 2 homework assignments, the angle addition and the segment addition postulate. I see a question. So for the homework, for my at-home, I'll just collect it all when you come back. So I will do that for my in folks, my in-class people. They'll turn it in at one time, all the homework at the end, and then you at home will also turn in all the homework at the end. If you have a question, you can take a picture and send me a message, and I can answer a question, but I do not want to grade that many online homework submissions. Yes, at the end. Yes, I'll give you the homework one at a time. You'll turn it all in at one time.
So we're gonna.
So these are technically due Tuesday.
Brianna?
No.
Okay. All right, so I'm going to end the Zoom. Let me know if you guys have questions. We miss you. Do you guys want to say hello to your friends?
Boy, I'm not supposed to. You can't just do.
It is not being recorded. Everyone say hello.
What's up?
Okay.
Wait, what is that?
I'm like a roach.
Who's hidden?
We
miss you guys. See you soon.
Oh,